Alright, today we're going to be doing inverse property. Alright. Inverse property. What does that kind of sound like to you? Inverse. Backwards? Good. Reverse? Okay. Good. Kind of means that. Kind of means reverse. Kind of means... Alright. There are two parts. Inverse property of addition, right? Good. So number 2 will be inverse property of multiplication. So you realize the pattern, right? It's either addition or multiplication. Joshua, please write this down, just like everybody else. What I write, you write. All right. I'm going to ask you a question. Let's see. 5 plus what number is equal to 0? Negative 5. So, yesterday we had the 0 in here. We said identity. It's who you are, right? So if you're a 5, you want to keep yourself a 5. But today it's inverse. It's kind of like the opposite. So I'm going to add the opposite to get to 0. All right? So if I have 8 plus what equals 0? Negative 8. Good. Now, what if I give you negative? Negative 7 plus what equals 0? What is it? Positive 7. So if I give you a negative, the inverse would be a positive. Got it? It's the opposite. Right. It's basically, here's the definition. Not really. Add the opposite. Yes, I am. Add the opposite. Simple enough? All right. Add the opposite. Question. If it's x plus what equals 0? Nice. Good job. Negative x. So basically, x's can be any number, right? So if any number plus the opposite, which would be the negative to it, then it would be 0. Got it? Okay, multiplication. Yesterday we multiplied by 1, right? Now I want it to equal 1. So 5 times what equals 1? Yes. Well, hold on. Let me get one answer at a time. All right, 5. Negative 0. There's no such thing, but sure. These are all the answers you guys are giving me. 5 times x would be 5x. Okay. 5 times 1 equals 5. But I want 5 times what number? I want it to equal 1. Yes? Nathan? Half? What's 5 times a half? This is 2.5. Good job, Tion. Okay. 5. Stop. 5 times 0.2. 5 times 0.2. That's 10. Move it over. That's 1. Good. But I need you to write it as a fraction. So, yes, that is your answer, but I need it written as a fraction, which is, good job, 1/5. The reason I went here and I paid attention was because I heard the answer, so I knew someone in this area had it. That's why my attention went over here. All right, 1/5. Good job. Why a fraction? Because, okay, listen. This is why. It's a great question. It's a great question. Why? What if it's 3 times what equals 1? Yes? No. What is it, David? Right. That's why we don't write it as a decimal, because it would be 0.333. But fractions will always look like this. What do you notice? What's the pattern here? Right. This number becomes your denominator, and what's always your numerator? 1. So, for example, if it's 4 times what equals 1? Good, write it down. Yep. If it's 10 times what equals 1? No. Write it down. Do you guys see the pattern overall? So basically, whatever your number is, you write as a denominator. Okay? Good job. Now, what if it's -8 times what equals 1? Good job. Has to be -1/8. Why does it have to be negative? Because so the inverse property, Jamari, says it has to equal 1. No matter what you start with, your final answer has to be 1. Well, if I start with a negative, I need another negative to make it a positive, right? 2 negatives make a positive. So therefore, this has to be negative. And also, take this number and write it as a denominator. Well, this number is a negative, so this number has to be a negative. Okay? So what if it's -13 times what? Sorry, I kind of messed that up. You guys know. We tend to write the negative on top, but I kind of just messed that up. Sorry. You forgive me. Okay, so the rule is multiply by, I'm going to use a fancy word, reciprocal. Reciprocal is a fancy word. It's basically, that. You flip it. I like to write the 1/x. So you write it as a fraction, okay? 1 over the number. But officially in math land, it's called the reciprocal. All right? Now, here's the hard one. Follow along. See if you can figure this out. Let's see if you can figure this out. 2/3 times what equals 1? No, it's a fraction bar. What? What? Okay, so 2/3 times, you said, and someone else said 2/3. Well, that would give me 4/9. That's not 1. You don't add denominators. 2 over 3 times 1 over 3 is equal to 2 over 9. Yes? Good job, Kimberly. The reciprocal. You basically flip the fraction. Why does this work? What's 2 times 3? Times 6. What's 3 times 2? 6 over 6? 1. You know how when we divide fractions, we keep change flip? This is the flip. When you divide fractions, you keep switch flip. This is the flip, the reciprocal. All right. Let's try, now that you see it. Five times 7 is 35 over 35. I'm going to blow your mind some more. Listen. Because, let me go back to this problem, right? How do I write 5 as a fraction? Do you see how they're flipped? See how they're flipped? So when you start off with the fraction, you're just flipping it. You're technically, when you get this, it's not that you're adding a 1, it's the 1's already there. You're just literally flipping it. Alright. Give you a really hard one? Damn, good job. Okay. That I have given you all the questions I gave my first period. Look. Same problem.